caching is an important way to improve the performance of your APIs, and this applies to Django and any other backend framework or language. You can cache data that doesn't commonly change, and also cache data at your busiest endpoints in order to improve the API performance and reduce the load on your databases and the server. We're going to explore some caching techniques in this video using Redis as our caching backend. And we'll look at caching data that's not expected to change often, and we'll also look at invalidating that cache using Django signals. And all of what we're about to do will be integrated with Django REST Framework ViewSet actions. So let's get started. Before we do, if you want to support the channel, we have a Ko-fi page linked in the description and in the pinned comment. And I want to just thank everybody that's supported the channel via this Ko-fi page. Now I want to start by setting up a Redis cache using Docker. So we're going to set up a Redis Docker instance. And if you don't know about Redis, it's a very fast data platform for caching, and it also supports vector search and NoSQL capabilities. So we're going to install Redis in this video, but you will need to have Docker Hub installed on your system if you're using Windows or Mac OS. Now Redis is a key value database and it stores data in memory, although there are persistence options as well. And that makes it perfect for a cache backend in most production settings. Now if we scroll down on this page, which I've got a link to in the description, we have a sample docker run command. Now what I'm going to do is just copy this command, and we're going to go to VS Code and paste that into the terminal, and we're going to change some of these parameters. So let's call this Django-Redis. We're going to call the container Django Redis here. And as well as running it in detached mode, we're going to expose the port 6379 from the host into the container, and that's going to allow us to connect from this Django application on the host into the Redis database on the container. And I'm also going to pass the --rm flag, and that's going to clean up the Docker container when this is stopped. Now when we run this, let's see what happens. And remember, I've got Docker Hub running in the background. We get back the container ID, and if we run the docker ps command, you can see that we have a Redis instance that has now been running for 6 seconds. Now to use Redis from a Python application, we're going to install Redis Py, and that's a Python client for Redis. And we can scroll down to the installation section here, and we have a couple of pip install commands. What we're going to do is use the second one because it's better for performance. So pip install redis --hi redis, we're going to copy that and go back to the terminal and paste that into this virtual environment. We're going to install this into the virtual environment so that we can connect to Redis from Python. Now once that's installed, there's one more package I want to use, and it's this one here from Jazzband, and it's called Django Redis. This is a fully featured cache backend for Django. Now I think it's worth diving a little bit into Django's cache framework here. If we look at the sidebar on the right hand side, we have different options such as Memcached and Redis for setting up a cache. So Django natively has a Redis backend for caching. And what you do in order to set that up is you set the caches setting in your settings.py file, and you can set that to the Redis cache that's built into Django. Now we're going to use a couple of advanced features that are provided by Django Redis. So this is a slightly more fully featured backend than the one that's native to Django. What you end up using kind of depends on your use case, but we're going to use Django Redis. So let's scroll down and we're going to grab the pip install command here, and we're going to paste that into the VS Code terminal and install Django Redis. Now once that's installed, what we can do is go to the application's settings.py file, and I'm going to scroll right to the bottom of this file, and we're going to add that caches setting. Now that's going to be similar to the databases setting. It's going to be a dictionary in Python, and if we go back to the GitHub page here, to actually use Django Redis as our cache backend, we can basically copy these settings here. So I'm going to copy this, and let's go back to the settings.py file, and we're going to create this here. So we have a default cache similar to having a default database, and we're setting that to the Django Redis cache object. Now notice the location here, it's localhost and then port 6379, and we're using number 1 here. And this is just a number that indicates the database number that we want to use here, and Redis by default provides I think 16 databases that you can connect to. So for our caching, we're going to use database 1, and what we're going to actually cache is the product list page. So let's go to views.py. Now we have this class here, product list create API view, that inherits from the generics.list create API view, and that's going to allow us to not only list the products that are on the application, but also to create a new product. Now let's say we have a fairly static product list page, and we want to cache the API response from that page. By caching that, we're going to return the products to our clients very quickly because we don't need to hit the database and perform a query. This is all going to be in memory, and we can very quickly return that from the Redis instance. Now, of course, we need to consider what to do if a new product is added. It's not going to be in the cache if it's added, so we potentially need a way to invalidate that cache, and we're going to look at that later. But the question is, how do we actually cache the returned API response here? Now, I'm going to go to the REST framework documentation, and basically this works with the native cache utilities that are provided by Django. So for example, we have a cache page decorator. And if we look at what that does in the Django documentation, this basically caches the output of an individual view when you decorate the view with the cache page decorator, and you can provide a time in order to determine how long this is stored in the cache before it's expired. Now if we go back to the documentation in REST framework, in order to use the cache page decorator with a method in a view set, we also need to import method decorator as well. So let's bring those in at the top here from django.utils.decorators. Let's bring that in and go back to VS Code. Right at the top of views.py, let's just paste these in. So now we have access to method decorator and also the cache page decorator as well. We can now go down to the product list create API view. And let's just start the server for now. And what we're going to do is go to the API response on the browsable API. So if we send a GET request to /products, we get back this API response with the product. Now if we want to cache this response, we need to use the cache page decorator. So let's go back to VS Code. Now the product list create API view, when we get the list response, that's going to use a method on the view set called list, as you can see here. So we're going to need the method decorator here. Let's copy that and go back to the product list create API view. And we're going to define the list method. And I don't think we have it at the moment, so let's define this now. So we're decorating this, and to the cache page decorator, we're going to pass a number of seconds that we want to cache the response. So I'm going to cache it for 15 minutes. And what we can also do with cache page is we can pass a key prefix. I'm going to do that just now. So let's pass key prefix here as an argument. And we're going to set that to a given string here that we want to use as the prefix for the cached API responses on this list method that we're about to write. Now I'm going to use product list as the key prefix, and then we can write the list method just below that. And we can pass the arguments in here and define the logic of this list method. And we don't actually need to do anything except return the superclass list method. So return super.list, and we're going to pass through the request, the arguments, and the keyword arguments. So what is this doing here? This is the list method, and we're not performing any custom logic. We simply delegate to the superclass's list method, but what we have done is decorate this with the cache page decorator. And that means that the response to any URL that is passed to this list method is going to be cached, and that's going to be stored in Redis. Now one thing to note here is that every request to this page that has a different query string, that is going to have a different cache key. We're going to see how that works in a second. Now before we execute anything, what I'm going to do is override another method here, and that's the getQuerySet method. So I'm just going to paste this in here, and we're overriding getQuerySet, and I'll fix the indentation. All we're doing here is returning super.getQuerySet, but we are going to sleep for 2 seconds. Now the reason we're doing this is that the getQuerySet method is what's responsible for getting the database objects for the list view from the database. But when we cache the response of this list page, we don't need to go and hit the database because we can immediately return the response from the cache. So we're going to see that in action now. Let's save this file and go back to our API's list view. And that was in this page here. And the URL is /products. If we refresh this page, notice that it takes 2 seconds to return the response. And the reason for that is because the getQuerySet method is going to the database, and it's taking 2 seconds here in order to do that. But when we go back to the page and refresh again, notice that we get the response immediately, and that's because the API response for this URL has been cached, and we can immediately return the response. So this is very fast now, as it avoids that database access, and it avoids in the getQuerySet method the sleep for 2 seconds. Of course that's simulated, but in a real query to the database, it could be performing a lot of complex operations and joins, and it might take a while to actually complete that query and return the data to the client. So caching allows you to circumvent that, and it allows you to return a response very quickly. Now one important thing to understand about the cache page decorator that we're using here is that it's going to create a different cache entry if the URL changes. So for example, if we set an ordering here on the name column, again you can see that's taking 2 seconds because it's not going to use the previously cached response, because now we have a different URL here. And each one of these two is going to be cached in the Redis database. But once we do have that response and we refresh the page, we get the second response very quickly. So that's the purpose of caching. We want to avoid hitting the database if possible, and we want to return responses very quickly and improve the performance of our API, and clients therefore are going to be happier. So it's about improving performance, reducing the load on our server and databases. But of course, it only works with data that's relatively static and data that you don't mind being inaccurate for a small amount of time. So for example, here we have a product list page and it's paginated at the moment. We might want to turn pagination off, and we can do that by setting the pagination class to none. And if we go back here and refresh this page, notice that nothing has happened, and that's because the previous response was cached. And this is an example of the problem. If we want a different type of response, we're going to need to either wait until the cache has timed out, and remember to the cache page decorator we set that to 15 minutes, or we can invalidate the cache somehow and get back the different response, potentially containing new objects or removing deleted objects. Now, as you can see, with caching data, it's better if the data is not going to change frequently. Otherwise, you're going to have complex invalidation strategies. This works best if you have something like a product list page that we have here, where you don't expect to be adding new products every hour or every 2 hours. Instead, it might be every day or it could be every week that you add new products to your store. But in the meantime, you can cache that data for a given period of time. But we're going to look at invalidation strategies now. So if our data changes and we want accurate results, we do need to invalidate the cache when things are added, updated, or removed. One way we can do that is using Django signals. So let's do that just now and go back to VS Code. And we're going to add to the application here a signals.py file. So let's do that just now. And I'm going to paste some code in here and we're going to look at this code just now. So we bring a few imports in from Django. And the two signals that we're using at the top here are post save and post delete. And if you want to know more about signals, check out the video we did recently on this topic in Django. Should be appearing on the screen now. And we're also importing the receiver decorator and Django's cache object. Now what we've set up below is a function called invalidate product cache. And this is going to be called when a post save or post delete signal is fired on the product model. In other words, when an instance of the product model is saved or deleted, after that action occurs, we're going to call this function here called invalidate product cache. And we have a print statement here saying clearing the product cache. Now, once we've added the signals.py file, we can go to the applications.py file here, and that's called apps.py. And within the API config class, in order to register the signals, we can create a ready method here, and then we can import the signals from the current application. So from the current app, let's import the signals module, and then we can restart the Django development server at the bottom. Now what we want to do here is that when any kind of change operation occurs on the product model using a save or a delete method, we want to then invalidate all of the cache objects that have this prefix of product list. In other words, we want to remove all of these keys from the cache. And the Django Redis cache backend actually has a delete many function that we're going to use for this. And that takes a wildcard, and that's going to be useful as we're about to see. Now what I'm going to do is just stop the Django server at the moment. And if we run docker ps again, we get back this container ID for our Redis instance. And we're going to actually access that container just now. We can do that with the docker exec command, and I've made the terminal bigger here so we can see this better. We're going to paste the container ID in here, and that's going to tell us to connect to that container, and we need to provide a command to run, and we're going to run the bash command, and that's going to give us terminal access inside the Redis container. Once we're inside the container, we can use the Redis CLI, and if you're interested in a video on Redis, let me know in the comments. And we're going to access database 1, so we're going to pass the number 1 here, and that connects us to our Redis database. And this is the one that we're using for caching in the Django application. And in order to get all of the keys, we can use this command here, and that returns these keys to us. Now notice we have two items here that use the cache page decorator, and these all contain the product list key prefix that we specified to the decorator. One thing I should note is that this is a blocking call. You shouldn't use this keys all command in production. It's going to block your Redis database, but it's fine for testing and development. So we can see all of the keys in this database. And if you want to get the value that's associated with a key, what you can do is you can copy the name of the key. And if we clear the terminal, Redis has a get command, and we can paste the name of that key in there. And it gives us back the cached response essentially, which is a string here. And this uses the browsable API response. So again, what I want to do here, if we run the keys all command, is I want to actually delete all of the cache keys that contain this key prefix when this signal fires. So in other words, when we have a signal here that tells us that the product instance has been changed, or it's been deleted or created for the first time, we want to invalidate the cache. So we're going to use a function from the Django Redis package for this. So let's go back to the Django Redis documentation, and it's on the GitHub page here. We're going to look for the delete pattern function, and that allows you to delete all keys that contain a particular pattern, and it uses, or you can use, these wildcard operators like this. So for all keys that begin with foo and contain any strings after the underscore, you can use cache.delete pattern here, and it's going to remove all of those from the Redis instance. We're going to use something similar in our invalidate product cache function. So we'll remove the to-do here, and we're going to paste another comment. We're going to clear the product list caches. Now we imported the cache from Django, and now we have access to this delete pattern function, _pattern, and that's not available in the native Django Redis backend. So if you want to use that, you need to install the Django Redis package. And we want to remove all patterns that contain product_list from the Redis database. So we use the wildcard before and after product list, and remember that matches the key prefix that we're passing to the cache page decorator. Once we've done that, we can then save signals.py. Now I'm going to exit out of the Redis shell at the bottom, and we're going to start the Django server again. And if we go to the browsable API now for the product list create API, I'm going to refresh that and you get the response here for /products. And if I refresh this, it's being returned immediately, so that timeout is not being fired in get query set because we're not hitting the database. What I want to do is go to the Django admin, and we're going to add a new product here. So let's do that just now. Let's go to add product, and I'm going to fill these details out. Now once we have these details, we can hit save at the bottom. That's going to add a new product. But notice now when we go back to the list page, if we refresh this page, it's now going to take 2 seconds. And that's because the cache was invalidated when we added a new product. And if we search for this product in the response, right at the bottom, you can see that it has been added. When we refresh the page again, notice that we get back the response immediately and that product is still present. But what happened when we actually added the product was, if we go to signals.py, the sender was the product model because we actually created a product. After that was created, the post save signal would fire, and that's going to then call this invalidate product cache function. And the body of this function is very simple. It's calling cache.deletePattern, and it's removing all keys that use the product list prefix. And that means that for views.py here, all of the different URLs with different orderings and pages and other parameters, they are going to be invalidated because they have that key prefix. And this will also work if we go back to the admin and we take one of these products and we delete it from the database. So let's delete the test product, and we're going to remove that from the admin. When we go back to the list page here, if we refresh this page, notice that it's taking 2 seconds again, and that's because again that cache has been invalidated. And if we search for that test product, we get no results. The reason it's been invalidated, if we go back to signals.py, is because this time the post delete signal fired, and that then called this method. So one option you've got when you're caching API responses is to use the cache page decorator. And that's going to create an entry in the cache for every distinct URL that ends up calling that particular view. So if you have search parameters, ordering parameters that we saw earlier in the series, and pagination parameters, these are all going to be cached separately if the query parameters change in the URL. And that may or may not be what you want, but that's the behavior of the cache page decorator in Django. This is not a Django REST framework thing, this is specific to Django itself, and you can use that for caching any kind of Django response. And because we have potentially many keys that have this prefix, what we did in the invalidation method was we called cache.deletePattern to remove all of them from Redis. So caching is a complex topic, but Django does provide some useful utilities that integrate very well with Django REST framework. It's important to consider what you should actually cache in your application. Anything that changes a lot is not really a good candidate for caching, but things that are relatively static or things that you don't mind being slightly out of date for a small period of time, these are good candidates for caching, and that can improve the performance of your API. And it can also reduce the load on your database. Now I want to finish with one very quick demonstration at the end here. Remember, if we looked at the Redis client, we saw the cached response from this browsable API. Often when your clients call the API, they want a raw JSON response. And in order to do that, we can pass format equals JSON into the query parameters here. That's going to return the JSON itself. And remember, we create a distinct cache entry for every URL. And that means that a cache entry will be created for this one, and that will be stored in Redis. So if we go back to VS Code, and if I stop the server and access Redis again, we can then access that key. For example, this is the one here. And this time we don't get back HTML, we get back a JSON string. We could then take that and decode that and use that in our applications. So that's all for this video. We've looked at caching, and we've looked at Redis and how that integrates with Django and Django REST framework. And we've discussed why you should cache and the benefits that it might provide. We also looked at invalidation strategies as well, but that's a complex topic and one you should really be careful with. And of course, we discussed some situations where you might not want to cache your data, for example, with data that frequently changes. Now I'm going to do one more video on caching in this series. That's going to be the next video, and we're going to look at Django's vary headers, or rather the utilities Django has for working with these headers. And that's going to allow us to cache pages where the response depends on, for example, the authenticated user. So we'll look at that in the next video. If you've enjoyed this video and want to support the channel, check out this Ko-fi page that we have in the description, and stay tuned for much more content. Thanks for watching, and we'll see you in the next video.